Hello,
Hi Ajay,
how are you, Vivek?
I am good. I am good. How are you?
Good, good. How are you, Shipra? Shipra?
Yeah, good, Ajay, good. I think we are good to start. So I'll just have a brief introduction. So I see, participants have started joining, and it's time for us to start session. So I welcome you all to the session of Who Test Your Unit Test by Vivek Ganeshan. So he's experienced agile leader and coach, and it's wonderful, and we are glad that he can, he's joining us for the session and will be sharing his insights. So once again, I'm happy to have you all in the session, and please feel free to post your questions in question and answer tab, and Vivek will be taking those questions post the session. And after the session, we will request you to please go to the polls and give your feedback. So over to you, Vivek.
Okay. Thank you very much, Shipra, for the warm welcome, and uh, thank you everybody for joining this talk. And this particular talk is about who tests your unit test, and also it can be a first, chance for you to get acquainted to what is technical agility. We'll talk a little more about that. So before I start, I just wanted to do a short intro of myself. My name is Vivek, and as you know, I am a technical agility coach. We'll get to what that means later a little bit, maybe during the starting of this talk. I am a published author of two books. One is called Blameless Continuous Integration. The other one is called Metrics for Agile Product Teams. I also speak in conferences, and I learn a lot by attending other people's talks. I learned a lot in the last 2 days, and I also have a small team where we make two SaaS products. We have two SaaS products in market named Face Quest and Notes Alike. I am a hands-on coder, hands-on technologist. I like to open my IDE, write code, tinker with things, and I also volunteer at a Tech Coach Circle. Right, Tech Coach Circle is a community where people can improve their technical agility skills, and they can become technical agility coaches by joining Tech Coach Circle. We'll talk a little more about that later also. And I'm also an open source contributor. Of late, I'm not doing much, but I have been contributing code to Mozilla's website, and Hadoop was a software that I was contributing to, and I have a doc commit in Bitcoin, so it's not a technical commit actually, but that's another thing, right? So this is pretty much my background, and whenever I do this intro, right, what happens is people generally get confused about the word technical agility, and when I introduce myself as technical agility, people, understandably show this irritated face sometimes, saying, "Come on, man, yet another agility jargon." There are already a lot of agility jargons: organization agility, process agility, this agility, that agility, and you are now adding another thing called technical agility, right? And what do you even mean by that? Right? So I just want to get that past and then proceed further, right? So I want to start with what is technical agility, and then I can go further into the actual topic. That's how I would like to prefer. That way, you get that initial confusion solved. So when we run agile transformations, what we do is, often it is at the level of processes. Sometimes it touches the leadership. You basically hire scrum masters, you convert somebody into scrum masters, and then you train people. You create a position called product owner, and all these things happen. But then when we run agile transformations, more often than not, we don't change how the core engineering is done, right? And the problem with that is that without changing how the core engineering is done, how the developer's life is impacted, how the tester's life is impacted, or rather, nowadays it's a full stack developer. So dev slash tester slash operations person's life is impacted. We basically cannot create a successful agile transformation where, if you even look at the first principle of the agile manifesto, it talks about continuous delivery. This was back in 2001. They talked about continuous delivery, right? And continuous delivery will help you to become agile, and that basically improves your responsiveness to change, which again comes from the agile manifesto. So unless you change the core engineering, how things are done, it is very you will get agility with a lot of ifs and buts, right? Saying, okay, we are doing releases every 2 weeks, but it is not on production, and we are delivering working software, but it works only in my development environment. These kind of ifs and buts come when you don't change the actual core engineering part of it. And what happens when you want to change the core engineering part of it? Now many organizations are realizing that, and they hire technical agility coaches, people like me and some of the friends that I have. And we basically help the organizations to guide them organization and also their engineers, and establishing some core engineering practices, right, that result in agility. People who are already familiar with engineering practices, you would have already known some keywords like TDD, BDD, clean code, and all these things. So we sort of start that initiative. And apart from TDD, BDD, there are other things also we do. So this is a short introduction to what technical agility coaches do and organize. And one more thing is, right now there is a huge gap in demand versus supply of technical agility coaches, right? That is, every now and then I receive a request from some of the people. I am into consulting, so I am not a full-time employee anywhere. I'm doing freelancing. So people come and ask, hey, you know what, we need a technical agile coach. And I more often than not end up saying, you know what, let me check and get back to you. And then nobody turns out, and then I say, no, we don't have anybody. So particularly in India, there is a huge demand between huge gap between the demand and supply. And this results in technical agility coaches being in hot market for a long, right? Now this session particularly, you have come to this session, you have chosen to come to this session possibly because something around the title, because unit test, this, that, and all attracted you, and that makes you compatible to grow into a technical agilist, right? Agility has some technical components about engineering, so possibly you are compatible to grow into technical agilist. This session can be your beginning of your journey, right? But then this session is basically what do you say, a beginning, nothing more than that. If you want to hone your skills and become a technical agility coach, not by attending classes but by doing hands-on exercises with a lively community, you can also invest in a subscription of Tech Coach Circle, right? This is where I volunteer my time, right? This is one thing. Now that it is taken care of, let's come to our topic. Today's topic is who tests your unit tests, right? And I understand that not all of you can be technical, so I will make this talk as beginner friendly as possible, right? So we will start with very absolute fundamentals. So the first fundamental that I wanted to start about is what is code, right? So what do you guys think about it? Maybe you can put a line in chat if you want to, about what do you think is code. I know it's difficult to define, but let's try it out. Maybe anything that you guys think, beginner fundamentals. Okay, what is a code? Okay, my definition of code is set of commands. Correct. That is one more thing. So, something that can help us automate our work. Very nice. Piece of software for achieving a purpose. Yes. Instructions to make a system work. So each person defines code differently, but all of the different definitions, right? They converge at one point, saying code is nothing but something that tells the computer what to do. It is the way in which we communicate to computers, right? And this code is written by a coder, or sometimes we call them developer also. There are differences in these terminologies, but let's assume they are equal for the purposes of this talk, right? And this code is written in a programming language: Java, Python, JavaScript, many things are there, many languages are there. And this is code, right? Now, example of a code. So if you're a person who has never seen code, or sometimes people have this reaction, if you have not touched code for a long, people have this, what do you say, gut wrenching feeling when they see a line of code. So don't worry, I'm going to show you beginner level code all through this session. And even if you have not seen code before, don't worry, we will take you along, right? Until the end of the session. So I am having a code. I am calling it's a presumably JavaScript file. So I'm calling it JS, and it is called even or odd, and I'm giving an input x. And if the remainder of x divided by 2 is 0, I'm going to return even. If the remainder is not 0, then I'm going to return odd. So whenever I call this particular, we call this a function. Think of it like a block where you call something and it returns you something back, right? So this is an example of a source code, and we will use the same example all through this talk. So don't worry, I'm not going to show you a lot of different codes and scare you a lot, right? That's one thing. Now let's we have got code out of our way. Now let's start about test. right? So today's topic is about test. So what is a test, right? Any guesses from your side again on the chat window? Validate functionality that is built. Okay. Testing the code written. Yes. Verifying whether a code performs as expected. Very nice. So again, converging on the definition of the entire group, a test is something that verifies if the source code works correctly or not, right? You have a code which is supposed to do things for you, which is supposed to talk to your computer so that you can actually do some business on top of that code. So we call that code as a source code, right? And test is nothing but something that verifies if the source code works correctly or not. And this test can be a manual test or automated test. So this is where a lot of discussions around the agile conferences happen, where should we automate, should we not automate, a lot of things are there. When a human being executes the test, when human being verifies that the code works perfectly in some way or other, that is a human test, which is a manual test. And if a computer code verifies that, right, then that is called automated test, which means automated test is also code, right? Automated test is also code, and we want to go into the area of automation more often than not. There are cases where only human testing, manual testing will work. If we talk about test pyramid, that is another area that we can think about later. But automated test is also code. This is where the entire community is moving towards right now, for obvious reasons, right? And unit test. So now I spoke to you about what is a test, so I want to add one more thing called unit test, because this talk's title is who is testing your unit tests, right? So unit test is nothing but it's a test that verifies if a unit works correctly, right? Now that's not very helpful. What is a unit, right? And unit is nothing but the smallest piece of code you can test. So tying it all together, let's say you have a huge software, and in that, what is the smallest piece of code? It can even be one line of code. And if that is the smallest piece that you can test, then that becomes a unit. And a test that tests this unit is called a unit test, right? So unit test is nothing but a test that verifies if a unit works correctly. Unit can even be one line of code, smallest piece that you can think of. That is a unit test. And we are talking about sometimes unit testing is also wrongly misunderstood in different organizations that I've seen. Sometimes people think, okay, developer testing their own code manually is called a unit testing, right? That's a wrong definition. At least that's not what we are going to talk about in this particular session. uh, this session is going to talk about unit test in the sense that unit test is something that verifies if a small piece, if a unit works correctly or not. And there are other types of tests. I will list them, but you can read them up later in some other areas, right? You have something called integration test, where it checks the interaction between two different components. And there is something called acceptance tests, or it can even be called end-to-end tests, right? Where you take a system, instantiate it fully, and then check whether it works end-to-end properly or not. This is an end-to-end test, right? Now this is a unit test, and like I gave you example of code, right, that even or odd function, I'm going to give you an example of what a test looks like also. So if you see, I told you test is also code, right? So it doesn't look much different from the code that I gave you, where I'm going. This is a file again which I wrote in JavaScript, test.js. JS is JavaScript, right? Again, very same thing. It is called test even or odd, and and this can be a little tricky to understand, right? So I will highlight parts. You can highlight those areas. You can concentrate on those areas only. So every test will have to call the actual code. So this guy is calling even or odd. This is what we are wanting to test. So this is the function that we want to test. So we call that function with a specific input. So here we are passing the input of 2. So we are calling the even or odd, that code that we wrote earlier, and it is sending a value of 2 as input to it, right? So first thing is the test calls the code, and second thing it does is it verifies, right? This verification is also called assertion, right? Assertion is, yes, it indeed works in this way. That is called an assertion. So verifies or asserts if the result is as expected or not. So if you see, there is a command called assert equals, which means it verifies if two things are equal, right? So you call the code with input of 2, and you equal you check whether the expected result equal to result from execution, and here the expected result is even. So if it returns this particular even or odd, if it returns even, then this will pass, otherwise it will fail. So any test has to do these two things. It has to call the actual code, and it also has to verify if the output is correct or not, expected or not. These are the two things that any test is supposed to do. If let's say a test does not even call your code, then it is a useless test. It's not even a test to begin with. And second, let's say your code is called, but it does not verify anything, that is also a bad test, right? So this is what, these are some basic ideas about unit tests. We will expand on them a little bit to make our point about, who is going to test your unit tests. Now, important point is, we mentioned, and you also saw that automated test is also code, right? So we have test to test the code, but then if automated test is also code, then who tests that? That's the next question, right? And this goes like that, infinite, what do you call it, inception kind of a scenario, where you have levels after levels after levels, and you get stuck. But in this talk, by the end of this talk, you will not get into inception mode. You'll not go into infinite loop. You'll not go into, okay, who tests this, okay, then something will be there, who tests that, and then you will not go into infinite loop. I can promise you that, right? This talk is going to address that. Now, uh, this is the fundamental of what is a unit test, right? And we understood that somebody needs to test the automated test also. Just because somebody is writing a test doesn't mean your code is all great. Just because the tests are passing doesn't mean the code is all great. So I'm going to demonstrate that point of view with some concrete code examples right now. Right, again, beginner level code examples, same even or odd function I'm using. I'm not using anything complex, right? And same kind of tests I will be using. I'm not going to introduce additional code complexity in whatever my demos are, right? Now, let's go further. When you ask the question of how do you measure the effectiveness of unit tests, so you go to a team and you ask them, hey, do you write unit tests? Then people say, yeah, we write. And you ask them, okay, how do you know they are good tests? And they say, hey Vivek, you know what, we do code coverage measurement, and we have 80% code coverage, 60% code coverage, some number they will say, and that is the measurement that proves them that okay, tests are good quality. So this code coverage may not be a easy term for people to understand. If you already understand, that's fine, but I also want to introduce that term to you. So what is code coverage? When people say they have 100% code coverage, 50% code coverage, what does that really mean? I wanted to show you that. Now, we already have a source code. This is the code that actually does the business functions. And let's say there is a file called source code.jsx, and it has 10 lines of code. So 1, 2, 3, 4, 10 lines of code is there in your source code. Now, there will be an automated unit tests. I showed you unit test, right? Like that, you write multiple unit tests, one after one after one after another, to check different units, and that becomes a unit test suite, which is nothing but a collection of unit tests, right? And this entire test suite is going to verify your source code. That is the whole functionality of test suite, right? Now, in this case, let us say we wrote a unit tests, or we wrote a set of unit tests which verifies the functionality, but while it is running, it touches only line 2, line 6, and line 9. So when I run the unit test, it will run the code also, right, internally. So when I run the unit test, it internally runs the code, and what lines of code it touches, we found out that whenever I run these tests, it touches only line 2, line 6, and line 9, which means this is effectively covering only 3 lines of code, though there are 10 lines of code. So 3 out of 10 lines are covered by the tests, right? And so we say, okay, 3 divided by 10 is equal to 30 percentage. So the code coverage is 30 percentage. So this is one variation called line coverage, right? And this is what we mean by code coverage. Now, uh, now that you know what is test coverage, how typically people use code coverage is that initially when you are not writing unit tests, you can see organizations or teams saying, hey, you know what, let's set a goal to achieve X% code coverage by a specific date. So by the end of this month, we need to reach 60% code coverage in our code base. This kind of goals they set. And if the organization is already having code coverage, they are already writing unit tests, then they will say, I'm going to set a threshold And 60, I'm not advocating 60. I would always advocate 100% code coverage. So don't think 60 is just so 60 is what I'm advocating. This is an example, right? So don't think 60 is a good number. So what organizations do is they set a threshold of 60 percentage or 80 percentage or 100 percentage, and they say any new change that goes into the system should not go less than this threshold. This is something that these are the two ways in which they typically use the code coverage as a metric when organizations or teams start using code coverage. Why do they use code coverage? They want to measure if the tests are meaningful or not. That is their goal. Now, let me show you some things that can go wrong when you do this, right? So I will show you something, and we are going to talk about what is wrong in this. So the source code, nothing changed here, even or odd of x, same. If reminder is 0, return even, return odd. This is something that you have already seen in the previous slides. Now I have written a test which calls even or odd of 2 and even or odd of 3. So how do you calculate the code coverage for this particular test? So you see, even or odd of 2 is going to call this function, and since the number is 2, it is going to return even. So this line is covered by the first line of test, covers the first line of code in this example. Similarly, when even or odd of 3 is happening, when that is called, it is going to cover the even or odd of 3, which is going to cover the second line. It is going to return odd. So your test has covered the entire code is 4 lines, out of which only 2 lines are executable. Other 2 lines are structural parts. So 2 lines are there and 2 lines are covered by your code. What is your code coverage now? 2 lines are there in the code and 2 lines are being covered by the test. How much is the code coverage? Any guesses? Maybe in the chat. 100%. Yes. So this is a very good scenario. People generally think, wow, it's a great thing because my tests are, this particular test is a good test because it does 100% code coverage. Now let's delve deeper, right? Is this really a good test? Let's talk about that. And why is it not a good test? Maybe any guesses or any opinions that you have? Why is this not a good test? Some people are saying, no, it's not a good test. Why is it not a good test? Okay, there is something negative. It doesn't cover with all possible data. That is one. Okay. Anything else? Okay, even if people are going to, yes, negative scenarios is one thing. Even if, let's say, I write 100 tests in the same format, right? Assume that I'm covering all scenarios in 100 different tests. Will this still be 100 good tests or 100 bad tests? The problem here is that I'll show you what the problem is. Problem is there are no assert statements. You are just calling the code and leaving it. You are not verifying anything. A test is supposed to verify the output, right? What you are doing here, you are just calling the function with a input of 2 and you don't care what it returns. You're okay with anything that it returns, right? Similarly, you're calling 3 and you don't care what it returns. So even if it had written potato, you would have passed the test, right? So this particular tests are bad because there are no assert statements at all. And this is a very common thing. So whenever I go to teams which are having a high pressure scenario where, in the last day, they are pushing the code and they have this threshold, right? So without this much coverage, we will not let it go. So people who do test last, or, in the last day, people write test in order to, meet the coverage, people do these hacks, right? This does not serve anything except to meet the metric. So there is this law, right? When you measure something, that becomes the goal, right? So very similar, you start measuring threshold code coverage and people will give you 100% code coverage. And this is one of the tricks that people employ, not because they are bad developers. Remember this, most of the times these things happen because the people who set deadlines probably do not understand the beginning, why there needs to be 100% coverage. That's one part of it. Second part of it is there is a time pressure involved, so they have to release, and this becomes a release blocker if the code coverage is not met. So people will try to meet the code coverage by hook or crook. That's what happens. Now uh, when people understand this, so it's not very difficult to catch up to this problem, right? So you attended this conference, right? So the first thing you will do is, when you this if this is a surprise to you, you will go back to your team and say, you know what, hey, I am putting a new rule, and this rule is that I am going to enforce you to write at least one assert statement per every test. right? So now what happens? This seems to be a good enough solution. It's a common sense solution, right? And you can even say, okay, I'm going to do random checks, or my architect is going to do random checks, my senior dev is going to do random checks. If a person does not put a assert statement in their tests, then things are not going well. Now this also has a problem. I'll show you a test which has 100% code coverage, which has assert statements, but still they are bad. Okay, I'll show you that example. So the second example is this is such a beautiful test which will look very good, very green in the all the reports, but it is actually not doing anything. So in this test what we are doing is, code is same, you don't have to relook at it. Code is the same. The test I have changed it to, okay, somebody forced me to write assert statements, okay, this is what I will do. Shortest possible, simplest possible thing I can do to breach that rule, or rather follow that rule, right, without understanding the principle is, I'll just put assert not null, which means as long as it returns anything, I don't care, right? So it just checks whether the value is not null or not. And your code never returns null. So this test again will have 100% code coverage. Similarly, it already has 100% code coverage. There is nothing to be improved there. But you enforced a rule and people a rule to add assert statements, and people added these assert statements. Again, this has 100% code coverage, but these are not good tests because these are useless assertions, useless checks. What if you're asking you're asking is it returning something, then I'm good with it. That's the assertion that you're doing, and that's not good enough. That's not what you want your software to be known for, good quality for, right? So this is also a bad thing. Now what is the correct test case? How does it should look? In case you are curious, okay, what is this, he's showing me all the wrong examples, where is the right example? So this is how good tests will look, where you are even or odd you're calling it, and you're asserting with a specific value. So specific input, specific output, you need to verify. That is a good test, right? And you can always add more cases, that's fine. So you can always add multiple tests also. One test will check whether it is for 2 only, another test for 3, another test for 4. But as long as the other assert statement includes a specific input and specific output, then that is sort of a good test because it actually checks the functionality, right? So this has 100% code coverage again, and it has meaningful assertions, so it is a good test case. So what we saw so far, I showed you some examples where you have super duper 100% code coverage, but it is a useless test. And I also showed you how we can write such tests. And in one test you can fix this. What if it is at scale? What if you have 500 tests floating around in your system, and how do you even comprehend whether this is happening or not? This is not possible, right? You can do it one level, one test, two test, you can see. How can you check 500 tests to see if this is happening or not, right? So that is why code coverage alone does not help you in enabling to measure the code quality, sorry, test quality. Code coverage will not help you understand your test quality. This is your takeaway now, right? I'm still talking only about the problem, right? General consultant mindset, right? We talk about solutions at the last possible moment. So we are still trying to find out problems with what the world is doing. That's what we are still doing, right? So I'll list down what problems we have, and then we can probably go to solution, right? So what is wrong in depending on code coverage only? So we are not saying code coverage is a bad thing. Remember this, code coverage is useful to see whether people are writing tests or not. You may be in an environment where people may not even be writing unit tests. In that case, code coverage may be a good thing to see if people are writing tests or not. That is a good thing. So don't say, okay, tomorrow onwards, I'm going to delete all the code coverage related plugins from my Jenkins. Don't do that, right? Code coverage is still an essential. That gives you some information, but that is not all information to infer the quality of your tests. So code coverage, if you depend on that alone, then what happens is that it only ensures that people write tests. It doesn't tell you anything else, right? Now, apart from that, it does not ensure the quality of test. Well, the popular belief is that you have high code quality, which means super duper code coverage, which means, sorry, I have super duper code coverage, which means I have test quality is high. And but still there will be a lot of bugs that come in production, and people keep asking, okay, hey, you know what, your code coverage is 90%, but why are you getting so many production defects, right? And we don't have an answer, and we try to say this or that and all these things, but it never really gets into a reasonable answer, right? the reasonable answer is because of this. Why we are not able to get a reasonable answer despite getting 90 or 100% code coverage? Why we get production defects, right? Now, additionally, it is very easy to write bad tests just to meet the code coverage target. When you set a code coverage target and enforce it on people, and even I've seen people, I've seen organizations where code coverage impacts your appraisals, right? And whether your code is really meeting the coverage or not, that sort of goes how many times your build was flagged for code coverage problems, right? And that's a problem, right? And it's easy to write bad tests just to meet code coverage target. And most important thing, it's not just you are not getting the mental safety. There is even more bigger problem at play here because of this useless and bad test. You saw the tests that we wrote without assertions, without meaningful assertions, useless assertions, all these things still run, right? And they are still going to run in maybe some place, maybe in your Jenkins or CI server, somewhere it is going to run. And while it is running, what are you doing? You are waiting for the build to complete. Now, if that is the case, whenever you want to do a release, you are dependent on these things to run, right, and pass in order to do a release. So your lead time basically of how quickly you can put things on production whenever there is a burning issue, you still are going to wait for these things, and when the build passes only you're going to put in production. So your customer has to suffer for a longer time because these are going to add to the execution time of your value delivery process, execution time of the test, execution time of your CI/CD process. And this is going to potentially delay the time by which your customer is going to get something out of it. You are pushing a bug fix, it's going to get unnecessarily delayed for no good reason. Useless tests are going to run, and they're going to keep you occupied, they're going to keep you waiting, and more often than not it is going to run in some place where it costs you CPU cycles, right? And if you're running in a cloud environment or something, you're going to pay by how much compute you do and all these things. So you're it's not just waiting time, it's also cost that gets impacted when you do only depend on code coverage. So useless tests are actually very costly affair, which we generally do not consider, right? So these are the four things that are wrong when you depend only on code coverage, right? So now I have come to the end of my bickering or cribbing about the problems that are there in the world. So consultant first half is over. Now next half is about how to solve that, right? So the second half is about, again, the problem is if you go towards the problem, it's basically you don't go and ask for quality. You say you try to dumb down the quality into some metrics and people play around that metrics. So even if things are not working, they'll say, hey, you asked me 80% code coverage, I gave you 80% code coverage, now what? Right? And people might even be defensive about that. So that's the idea here, right? Now, what is the solution? Solution is there is something called mutation testing, and I'll explain that to you. And this is the most often used method in order to make sure that your tests are of good quality, particularly unit tests, they are of good quality or not. That is going to be decided by something called mutation testing. So I'll explain that to you now. Now, what is mutation testing? So you already saw there is something called a code, which we saw already, and there is something called a test. So don't think these boxes are to scale. Sometimes you may have 3 lines of code only, but there are 100 lines of test. That is still possible. So don't go and tell anybody that, okay, your code is 100 lines, why is your test 2 lines, 200 lines? Don't do that. Test may more often than not, test may be bigger than code. So maybe next time I do this talk, I have to switch the names here. And you have code and you have your tests, so you call this a test suite. And what you do is you use something known as a mutation testing tool, and this tool is basically a software, right? And what this tool does is, what this tool does is, first, it looks at your code and introduces intentional bugs in your code, right? And remember, it runs in a isolated instance, so it is not going to make your change the code and check into your GitHub. It will not do that. It will not make any changes in someone else's machine. It just takes a local copy of the entire code and introduces intentional bugs in the code. right? I will demonstrate this also to you. I'll basically show some examples so that you understand this better. For now, understand that this person is intentionally putting bugs. Okay, why does he put that intentional bugs? Because he wants to check whether the tests are doing their job or not, right? So it is like this penetration testing, right? What you do is you breach the system and see if your existing security systems can catch it, right? Very similar. You give the job of this to mutation testing tool. It will introduce the intentional bugs in the code, and after introducing the intentional bugs, it will run your tests, right? Now, if your tests are of really good quality, if your tests are super duper tests, then they will fail, because this guy introduced intentional bugs. A buggy code should not pass the tests, so the tests will fail. So if the tests are not failing, then your tests are bad tests. But if the tests are failing, then it is a good test, right? I'll go through this again one more time. First, this tool will intentionally introduce bugs in the code. Why does it do that? Because it wants to see if your tests are really doing good job or not, right? It is checking whether the security guard is doing the job when I'm going to rob the bank, right? So here you are basically trying to steal a small amount of money from the bank, and you basically see if the security guard caught you or not. If the security guard did not catch you robbing the bank, then the security guard is useless. Right? The very same analogy here. So it checks whether the tests are failing or not. If not, then the tests are useless. That's what we do. And there are open source tools. You don't have to spend money on these tools. So whenever we talk about tools, people get scared. Okay, hey, you know what? I get a new budget. No, you don't have to get a new budget, at least for purchasing licenses for these tools, because any technology, if you're coding in Java, you use a tool called PyTest. Right? If you're coding in JavaScript, you use a tool called Striker Mutator. And every mainstream technologies, don't go for Fortran, COBOL and all, but for any mainstream technical stack, you will find at least one open source mutation testing tool. That's something that is readily available, right? So I gave you examples of PyTest and Striker Mutator. So I'll show you how it works also. So again, the same code example. I did not change anything. You have seen both of these code examples already. Source code, no changes. Since the beginning of the talk, the same source code is running. Test, this is one of the bad tests that I showed you, where there is an 100% code coverage and a useless assertion because it's asserting not null, right? So let's run through this in the mutation testing. How does it work, right? So one of the mutation is nothing but an intentional bug. That's why it's called mutation testing, right? Intentional bugs. What does it mean? So what this guy will do is, this particular tool will do is, it will silently go and replace this x percentage 2. It's here, no? It will replace this x percentage 2 into x plus 2. One of the simplest changes, but it is a bug, because percentage means remainder of the division, plus means addition, right? So if I change that percentage to plus, expectation is that the test should fail, right? But what will happen? These two tests will pass, because this test is not checking any output. It is checking whether there is any output or not. Any output you give, this guy will be happily passing the test, right? Same thing, right? You give potato, this guy will say okay fine, is this even or odd? That guy will say potato, and you are done. That is what it is trying to do. Similarly, I'll show you another mutation. So what happens is that this mutation, or this intentional bug, this mutation survived, which means our testing guy, our security guard, did not catch this particular thief, right? Another example is, it can replace this equal to operator is there, no? This will check whether it is really equal to 0 or not. Instead of that, it will put 0, sorry, less than. So if you replace this, it will become x percentage 2 is less than 0. Then also, if you see, these two tests will pass. So this mutation also survived. So you created two mutations, which is two intentional bugs, and two of them survived, right? And your security guard or your test cases did not catch any of these two bugs. So 0 of two mutations are killed, which means this bug is not killed. This bug is not killed by the test. So 0 of two mutations killed. So it's called 0% mutation coverage. Let's say if one got caught, no, so you'll say 50% mutation coverage. And simplistic example, I don't want to complicate it, so I'm not showing a big code coverage, big code sample, right? So your mutation coverage is 0%. And what we want to do is, instead of using code coverage, which is nothing but how many lines your test touches, instead of that, if you use this, This basically can tell you, not instead of that, I would say addition to code coverage. If you use this, then it basically tells you whether your tests are of good quality or not, right? And also I'll show you one example report. So if this is 0% code mutation coverage, right? So these are all bad tests. This is the idea that you have to get to, because your mutation coverage is not good. That's the idea. Now, any mutation testing report, sorry, tool gives you a nice report also. If you see, this is my entire code, which has a lot of lines, and my at a full entire code level 59.52, which means that almost half of the bugs were caught, half of the bugs were not caught. So if you see, total detected is 75, undetected is 51. So totally it tried to do 126 bugs. Out of that, 75 were caught, 51 were not caught. So this 51 is a problem here, right? 51 bugs can go to production in this source code. And you can also go deeper and say which part we are talking about also. So each line of the code also you can see, right? This is something that you can see, right? And you can also go and find out what exact change it did also. Let me see if I can uh, pull up a live report, and maybe I can show you that. Just give me a second. I'm trying to. Yes. If you see, this is very similar to what I showed you in the slide. And if I want to find out what went wrong, let's say I want to find out what went wrong in the success component.js file, right? I'll click on this, and maybe let me zoom it in a little bit so that you can see, right? And here, if you see, it talks about survived 6, right? So let's talk about wherever that red dot is there, that is a survived. So if I click on this, it will tell you what it tried to do. So instead of this entire line, it just opened the braces and closed the braces and see if if the bug was caught or not. So there is one line of code. Line number 6 is there. So what our mutation testing tool did is, it just deleted this line and closed the bracket immediately without that line. Still the test passed. Now you know that you have to write test for this particular scenario. So you can actually ask the developers to cover these scenarios, and this can even be integrated into your CI/CD cycle, so that people can know what lines are not covered and they can go and write tests to cover those areas. That's how it works, right? Now, going back to the presentation, I'll show you a summary of whatever we discussed so far, right? What is advantages of using mutation coverage? It basically measures the true quality of test, which is the point that I'm trying to make since the beginning. And open source tools are available to run this. There is no extra, licensing cost that you have to pay for doing that. And the third and the last important thing is, it can easily be integrated to your CI/CD pipeline. Every CI/CD tool has a way to integrate this mutation testing framework inside it. You just probably need to do an enabler, or you call, some people call it a technical story in some organizations. You just need to do that in order to see if you can really integrate that in your system or not. So you can do a research and integrate it, right? This is the idea here. And basically, I wanted to summarize whatever I spoke about just now. I told you initially what is technical agility, where core engineering methods need to change to achieve the agility without ifs and buts, right? Example is, we deploy every 2 weeks but not to production, right? That ifs and buts are not there, because are there because core engineering has not changed. You still do the very same things. So one of the example is test driven development, behavior driven development. These things can basically push you towards actual continuous delivery rather than just checking the boxes. And orgs hire tech agility coaches to help in this. So I was also putting a call to action for you, where if you are interested in this area and if you wanted to become a technical agility coach, this could be your beginner, like, first experience of what things you probably can research on, right? And we spoke about some fundamentals. Unit test verify the smallest piece of code, and unit test is also code. So we need to make sure they are of good quality as well, because again, they are also code, so something needs to be tested there also. They can go wrong as well, right? And the regular route to unit test quality is code coverage, and it just tells you whether people write tests or not, and they're easy to hack, and people write bad tests because of that. Alternate route is mutation testing, where there is an intentional introduction of bugs, and it checks whether the tests fail after the bugs are introduced or not. and then you can get a nice report on all these things we saw. I also showed you a publicly available report. You can just search for robobar or striker mutator. They will give you a sample report. And there are also free tools available, and you open source tools, and you can easily add it to your CI/CD process, right? This is pretty much the summary of what we spoke today, and I'm open for questions. If there are any questions, you can put it on the chat or Q&A window, and I can take a look at them and answer them.
So, yes, Vivek, we have a question from Krishna Bhaskar. The question is, can you suggest a mutation test tool for Microsoft development platform, please?
Yes. What I am going to do is, I don't remember the tool's name, right? But what I will do is, I'll just go to Google and search for Microsoft mutation testing, right? Or .NET basically, right? .NET mutation testing, and it already seems to have something in the direct framework itself, right? There is something called mutation testing.exe, right? I also have to research. The short answer is I also have to research the exact tool name, but it's easily, findable online. That's what I would say. There is something called Ninja Turtles, right? That's what I am seeing. First post where they have something called mutation tests. So Ninja Turtles is a platform. It's a Nugget kind of. You can see that in the Nugget repository. So Ninja Turtles seems to be something that you can try if you're into .NET.
And also, we have a question from Prem Prakash Dayal. So, these FDD or TDD are all tech agility principle as well.
Yeah, so this TDD, BDD, all these things we do, right? Think of them as workout programs that you need to do in order to, be that get into that continuous delivery path. So these are all the things that you do in order to do continuous delivery or frequent deliveries. Even if you don't want to do every second release, but if you want to even release once in 2 weeks, then you might need to start with all these things so that you are always release ready. So the primary principle becomes that you should be always release ready, and you should be able to release very quickly whenever you want to release. For that, these things help you. So test first approach, this TDD, BDD, all these things come under tech agility, right? We call them engineering practices. Some people call them DevOps practices also. Like this, many other names are there. But think of technical agility as an outcome that you get, where your software is agile in the sense flexible, so that it can change as and when you want to change. And DevOps is one way to make sure of that, and a lot of things come under that. So technical agility, think of it as an umbrella. I'm not sure if I confused. I see. Okay, but so that's the thing. Yeah. Any other questions?
Okay.
Confusions?
Vivek, yeah, I cannot see any more questions. So please, if anyone has questions, you can post it. We still have few minutes left, and also request people to please vote for the session by going to the polls, and you can give a feedback for the session. So Vivek, thank you so much for giving us so much insight. I never thought, that, this how unit test and how can people make us fool, and as coaches it's an eye opener for me as well. So thank you so much for those insights and for those learning key takeaways. So I think we can just wait for more minute if in case anyone has more questions. So we'd like to thank all the participants and Vivek for your insights. So
Thank you
please,
very much.
thanks. So in case you have a question, so please let us know. Vivek is here for few more minutes, so please feel free to ask your questions, and please remember to give your feedback
Yeah, there is
by
one
going to the
question,
poll
that what
section.
will be there in the Tech Coach Circle subscription, right? So I'll show you. You can take a look at what all things are there by going to techcoachcircle.com/members corner. So here, if you see, there is a members corner. So this is what you get. Basically, you can take a look at it. You have some samples also. We do desorganize every day. Like this, many samples are there, so you can take a look at it, and that can be a starting point for you if you want to know what things are there in Tech Coach Circle.
Vivek, there is one question from
Yeah.
what all we have in TCC subscription.
Yes, yes. I was trying to answer that actually. That's what I was showing you here. Uh, uh, are you
The
able to hear me?
Yes.
Yes, Vivek, you're audible.
Yeah, yeah. So to answer that question only, I pulled this up actually,
Okay.
where
Yes.
in the TCC subscription you get all these things. So this can be a point, a place where you can see, what is there, and you can even go deeper to see what exercise sets are there or everything. So the idea is hands-on learning rather than doing sitting through 2 days or 3 days of training, because these are involved topics, right? That's the idea there. Any more questions?
Vivek, can you place that link in the chat?
Sure, sure.
That will be
I'll do
better.
that.
That will be better because people can check. And
I'm doing it right away.
yes, thank you, Vivek. And thanks,
Yeah.
Vivek, for your
Thanks, Vivek.
wonderful session. It was a very great session. Testing has faced a lot of things. TDD, BDD, and
Yeah.
good. As a
Thank you.
nice session, right inside session. Thank you. We'll
Thank
wait
you
for
very much, Ajay.
we'll wait for a few more minutes if you have any questions.
Yeah. And in case you want to have a chat, feel free to, chat me up on LinkedIn also. That's perfectly fine. Right.
All right. I think thanks, Vivek. I cannot see any more questions coming in. Thank you so much. Thanks, everyone, for attending the session. Thank you.
Thank you. Bye bye.
Thank you. Bye.
Is it okay to drop off Shipra, or should I stay for some more
Yes,
time?
yes, yes, Vivek. It's fine. Yeah. Thank you so
Okay.
much.
Thank you very much, Shipra.
All right.
Thank
Okay.
you. Bye bye.
Bye.